This conference will now be recorded.
Okay. So as you are aware, in VLSI there are two domains are there. One is front end domain, one is back end domain. Okay.
Sir,
Yeah.
sir, this session is for System Verilog November batch or December batch, sir?
No, no, this is not a system Verilog session. I have said right today we don't have a session. You
Sir,
will
but
only have the
for December System Verilog batch, we have a session, sir.
December. So
Yes.
this is not the link, right, for you.
Yeah, but I have got the message in WhatsApp to join this class, but
This is not the one. Please connect with the institute admin. He will help you.
okay, okay, thank you, sir.
Okay. Sure. Thank you. You see, in VLSI, there are almost 15 steps are involved. Starting from the time we list down the requirements till the time we do the packaging. I mean, this is all it goes through before the chip actually gets packaged into a final product. So what, as a training, what we do is we divide this entire thing into two major domains. One is the front end domain, one is the back end domain. Now, what is the differentiation? Let us discuss today. So, front end domain is more focused on programming oriented. 1 minute, I'll just. Okay. So, the front end domain is more programming oriented job. The back end domain does not involve much of programming. Okay. So, having said that, let's now get into the agenda. What we are going to talk about today, and what will be the focus of session. So we'll be basically focusing on understanding what are the courses that we are going to start today, and the brief overview of the institute, little bit understanding of the electronic system, just to help you understand what is VLSI and what is embedded systems. A very brief about this. Please close the door. So we'll understand also about the front end domain flow and the back end domain flow. Then we'll talk about what is the skill set required in different domains of VLSI. Okay. And how do you choose the right domain? And little bit about institute facilities and how do you prepare for the job. So I'll just brief about it. Some of you might be attending DFT training. Okay. Even for you, this initial 1.5 hour session will be relevant for you because we are just going to. I'm not going to go technical into functional verification. We would be rather talking more about the design flow. What are the different domains, and what is the skill set required, so that it will help you make a right decision. Okay. Those attending online, please be in mute. Okay, fine. So just about myself, I'm the founder of the institute. I handle the all the front end domain related activities in the institute. Okay. So what are the courses starting today? So as I told you, as I told you, in VLSI there are majorly two domains. One is the front end domain and back end domain. Uh, Even in front end domain, there are multiple sub aspects are there. What we call RTL design, RTL integration, and RTL verification. Design, integration, and verification. In the backend domain, we have various domains like synthesis, STA, physical design, custom layout, physical verification. So there are various aspects are there. So it is difficult to do demo session for every topic. Rather, what we do is we majorly keep two demo sessions. One is the demo session for front end domain, Other is the demo session for the backend domain. And specific to each subdomain, we'll have a separate topic. I mean, short demo session. Let's say for DFT, you'll have a demo session today. Uh, Tomorrow we will be having the demo for entire backend domain, which will give a overview of the everything we do in the backend domain. Then those who are interested in layout will have a separate 1 or 2 hours demo again. Those who are interested in, let's say, synthesis and STA will have a separate demo. Okay. So today's demo is completely focused on the front end aspect of the design flow. So I'll be touching upon whatever agenda. I'll also give you a brief about what is functional verification and what is the skill set you require to get into functional verification domain. So what are the courses starting today? One of the course that we are starting is the RTL design and functional verification. The same course, whatever we are calling as RTL design and functional verification, we can call it as, I mean, some people may refer to it as front end training for freshers, design and verification course, functional verification training for freshers, ASIC verification. All of them are referring to the same course. Whether I call this one, sorry, whichever name I refer by, I'm referring to the same course in all these all of them. The other course that we are starting is the functional verification training for experienced engineers. So the difference between these two courses, the fresher course and the experience course, is that this will have digital plus Verilog additionally. The experience course won't have the digital and Verilog, because when we say experienced person, we assume that the person would be familiar with the digital and Verilog related things. The person only wants to prepare on system Verilog onwards. So that is where this will differ, and UVM little bit advanced will be there. So the difference is what? The experienced person course, functional verification for experienced, will be functional verification for freshers minus digital minus Verilog, no digital, no Verilog, plus UVM advanced topics will be there, which is not required for a fresher. These topics, which are done for experienced people, they are not required for freshers. So this is the only difference. Otherwise, rest of the syllabus remains same. Because we are removing digital, because we are removing Verilog, automatically the course duration will come down, and automatically the fee is also less, because we are removing two major topics. Next. Now you may say, why does an experienced person need a training? He's already working. Why does he require a training? Many times what happens, someone who is working in the job, even into working into verification itself, they don't get to work on the entire flow. They will only work on one small aspect of the flow, where they don't get exposure to everything. So our course will help fill that gap, will ensure that they get that entire flow exposure. Other than that, for someone who is currently pursuing their BTech MTech, they want to learn something into VLSI. So we have a small courses like Verilog and System Verilog, which they can do separately. They don't need to enroll for entire course to for this. So we are also starting Verilog and System Verilog today, and we are also starting FPGA design and verification. So going forward, we will, I mean, in the today's session, we'll understand that VLSI is design styles are two types. One is called as ASIC, one is FPGA. What exactly is ASIC and FPGA? I'll talk about it. Okay. Uh, FPGA is I mean, as the name stands, field programmable gate array. Okay. ASIC stands for application specific integrated circuits. So these are two different ways of manufacturing a chip. I mean, if I want to manufacture a chip that is going into a phone, for example, the chip can be developed either by using ASIC technology or by using FPGA technology. So we'll briefly talk about that as well. I mean, it is important for you to understand, because there are opportunities in both the domains. So we are also starting a course on FPGA design and verification. We are also starting a course on RTL design and integration. See, here the difference is RTL design is same. Here it is a integration course. Here it's a functional verification course. This course is majorly meant for experienced people. Actually, generally companies don't hire freshers. It is mostly meant for experienced people. Other than that, we are also starting DFT. Okay. Today's front end demo session will be from 9:30 to 12:30. Okay. The DFT demo, our admin will give. So initial part of the session today will be common for everyone. I mean, for everyone from these domains, initial 1.5 hour session will be common. Okay. The later part will be the one that differs. So the DFT technical session will be done later in the, I mean, probably post lunch. Our admin will inform you the schedule for that. So first, let's briefly start off with understanding of electronic systems. Why we are starting off with this is, I assume many of you are just graduated and you are new to the whole concept of VLSI. So lot of times people have a doubt between what is VLSI and what is embedded systems. Okay. Can someone tell me what is the difference between VLSI and embedded systems? Are they same? Are they different?
Yes, we use transistors in VLSI, but we use embedded system microcontrollers.
Okay,
Those
fine.
differences.
Okay, sure. Thank you for that. Anyone else wants to add any inputs?
Hello.
Yeah, please answer.
I think embedded deals with the firmware and VLSI deals with the hardware part.
Yeah, that is correct one. Okay. So VLSI is about what? VLSI is about uh, the process. I mean, process involved in developing of hardware. What is embedded systems? Process involved in developing of firmware. Now the firmware we can call it as the lot of things will be there. Linux drivers, they call it as Linux drivers, the device drivers. I mean, lot of they may still be same. Okay, okay, etc. So let's try to understand difference between VLSI and embedded systems through an example. Okay, first let's take one analogy. To understand what is VLSI and what is embedded systems, let's take one real life analogy that will make it easy for you to understand what is difference between them. Consider a bus with passengers. Okay. Tell me what all things are present in that system. If I consider a bus with passengers, who are all present in that? First, the bus itself is there. Then, who is there? For bus to go, who is required? Driver is required. Then, to manage the whole crowd and whole passengers, you need conductor. Then you need what? Passengers. So, for a bus to work properly, all these four are required. You see, sometimes you'll come across buses where there is no conductor also. Driver itself does both the things. That is also possible. Even in electronic system, that's possible. So here, assuming that all four are there. So bus is like a hardware. In our even in mobile phone, this is like a bus. The hardware you see is the bus. Driver is like the term driver. See, I use the term drivers. You see, Linux drivers, device drivers. What does the driver is doing in the bus? Controls the bus, controls the hardware behavior, means when to accelerate, when to stop, when to take turn, everything, right? Controlled by the driver. Can I, as a passenger, can I go and control the bus? No. So as a passenger I cannot do. This is can be called as firmware. Conductor is what? He is the point of contact between driver and the passengers. Whatever I want, let's say I'm sitting in the back of the bus, I want bus to stop, so I cannot go and tell to driver, so whom I will tell? Conductor. Even whatever, anything, conductor coordinates. So he's like a operating system. Then what is passengers? Are like the applications. You see in your mobile phone, apps are there, right? Okay, without apps, let's say your mobile don't have any apps, do you have much use of the mobile phone? No, right? Only because of apps you get a lot of value addition. Same thing. So the here point you have to understand is, if a passenger wants bus to stop, for example, what does he do? He will inform the conductor. So there is a communication that happens between the application and operating system. We call it as API call, application level interface call. Application level interface call. Then will the conductor go and stop the bus? No. What he does? He will inform driver. What driver will do? Driver will finally control the hardware, bus, and stop it. Essentially, that is how even the electronic system works. Now you see, for a bus to work properly, can I remove any of them from the system? Let's say if I don't have a driver, will the bus work properly? If I remove the bus itself, no, right? So hardware is required, right? Without hardware, you don't have, there is no meaning of firmware, operating system, and software. You remove passengers, there is no use again. It can still work, but there is no use. It doesn't do any productive thing. Okay. Same is the concept of electronic systems also. Any electronic product you take will have four layers. One is the hardware, which can be thought of as processors, camera, sensors, keyboard, everything. Okay, whatever you see is the hardware. Who develops the hardware? Who develops the hardware? It is. It is. Don't hesitate to answer. No problem. Even if you answer wrong, nothing. No wrong. Nothing wrong. It is the VLSI engineer who develops the hardware. Who develops the firmware? Or the driver. Firmware is also called as a driver. Who develops the firmware?
Embedded system engineers.
Embedded systems engineer. So this is the difference between VLSI engineer and embedded system engineer. So VLSI engineer is responsible for development of the hardware. Embedded system engineer is responsible for development of the firmware or the drivers. Either you call firmware or you call drivers, we are referring to the same thing. You understand, right? This is one thing I wanted I wanted you to understand. Okay. In a while, I will talk about what is involved in the development of drivers. We will also understand briefly what is involved. Third is what? Operating system, like Android OS, iOS, Windows, Linux. These are all examples of operating system. Who develops operating system? Tell me. This is software engineer, right? Then what do you have? Final layer, applications like the apps in the mobile, GPay, WhatsApp, Maps, everything is an app, right? Who develops them? Either software engineer or the app developers. All four layers are essential for electronic device to work, right? I mean, only when you have all four layers, it will work. Okay. So you got the idea, right? This one. Next, let us understand what exactly is drivers. I mean, when we say embedded system and firmware, what are those things? Because anyway, next 6 to 8 months, we are going to understand hardware only. When we say VLSI, whether you get into front end or back end, you're only focusing on the hardware development. Let us briefly, for 5-10 minutes, understand what is involved in the development of a firmware. Okay. Someone who works into firmware, like who is the equivalent of firmware in bus example? Who was the equivalent of firmware in bus example?
Drivers.
Driver is the one who controls the bus. It's the firmware which controls the hardware. Okay, it was the driver, right? So now let's understand how driver controls the bus. He has got 5 controls. Just we'll draw the analogy. We'll take an analogy and easily understand. Accelerator, brake, clutch, gear, then handbrake, various things, and the majorly has got steering. I mean, you may say, what is this has to do with VLSI? We'll understand this also. We'll understand that also. So basically, the driver is responsible for controlling a bus through the different controls provided to him. Same way, in VLS, in the electronic system also, the firmware, similar to accelerator, brake, clutch, and all these things, firmware accesses, configures, or programs the configuration registers present in the hardware to control its behavior. Let's understand this statement. The firmware, what does it do? It configures our programs the configuration registers present in the hardware to control its behavior. Let me explain it through a simple diagram so that you will understand it better. Okay. Okay. I'm not trying to make it any embedded demo session. I'm just trying to help you understand what is hardware, what is firmware. You should have a clarity, right, before you get into hardware. If this is my chip, this is a chip that went into my mobile phone. Let's say. This chip will have various subblocks. I'm just drawing few things, okay? Things connected to each other, basically. There will be various things connected to each other. This is an example of a SOC diagram, SOC architecture. It's called as what? SOC architecture. Who is responsible for developing this whole thing? VLSI engineer. SOC engineer is responsible, I mean, VLSI engineer is responsible for development of the hardware. What you are seeing is a hardware. So what does firmware developer do is embedded system engineer, either firmware developer or embedded system engineer, both of them are same. What they do is they develop something called as drivers. What they will do is when they are loaded into the memory, there will be a memory, there will be some memory, let's say assume flash memory. What is this memory? Flash. Are you familiar with flash? Different types of memories will be there. Flash, DDR, different types of memories will be there, into which my instructions are loaded. These instructions are loaded into the flash memory. This is a processor. You know, in your mobile also there is a processor. I mean, when you buy the mobile phone, you will ask what is the processor, right? In your laptop, everywhere processor or microcontroller will be there. What this processor will do is it will start executing these instructions. It will fetch those instructions and execute these instructions. Then what it will, because it is getting these instructions from the memory and it is executing, this will result in, let's say this is my some of the some hardware component, let's say USB controller, and I have connected a pen drive here. Assume I have connected a pen drive here. pen drive I have connected into my chip. What this processor will do is, because I have done this one, it will result in some transaction getting originated here essentially. The controller, in the controller there will be registers actually. What are these registers? I am calling as configuration registers. Let's understand the flow again. Let's understand the flow again. It might be little bit confusing, but still you will, by end of this topic, you would have got little clarity. What is hardware, what is firmware? Okay, the diagram you see is what? Is it hardware or is it firmware? It is hardware. The firmware engineer or the embedded system engineer is not responsible for development of this hardware. He don't have any role in this. Whose responsibility is to develop this hardware? VLS engineer. What is the role of a firmware engineer? He develops some drivers. He will develop drivers through which what it does is he will develop some code. Those code is essentially the assembly instructions. You know, right? If there is an ARM processor, these instructions have to be ARM instructions. If it is a MIPS processor, MIPS instructions. Okay, if it is Intel processor, Intel assembly instructions will be there. I mean 8085 x86 instructions, they will be there. So the person who develops these things is called as what? Embedded system engineer. So what does embedded system engineer does? He develops some drivers. These drivers are loaded into my memory. They are stored into memory. Like in your mobile phone, you store photos, you store videos. Same way that drivers are kept into the flash memory. Now when you start the processor, these drivers will get fetched, these instructions will get fetched. You know, you would have studied fetch, decode, execute. Studied, right? Fetch means you are fetching it from here. Decoding, what is the instruction? Execute means what? This violet line you see, what is that color? Violet, is it? This color you see, this will get programmed, which will in turn result in some transaction happening to the this one. This will result in some transaction happening to the this one, to the pen drive. Essentially, whatever the communication that has to happen between the controller and the pen drive is decided by the this application. I mean, how that communication will happen, how the packet should be created. I mean, there has to be some way, right, where my pen drive and laptop is communicating. See, when you are moving the data from laptop to pen drive or pen drive to laptop, there has to be some format. It is called as frames consisting of packets. So this person who develops that will define how the packet should be created, when to create, what type of packet to create, how much time to wait. So he controls that part of it. So let's briefly summarize. I'm not expecting you to understand everything because a lot of you are very fresh, very new to this topic. So even if you understand, get a basic idea, that is good. So my intention is that you should understand what is meant by hardware, what is meant by firmware. The hardware engineer responsibility is to develop this thing. What is the responsibility of firmware engineer? He is responsible for developing this, that instructions essentially. For that, he uses a language called as embedded C. You would have studied the language called as embedded C. When he develops in embedded C, he will. What is the language he will use for developing that? Not assembly, embedded C. I'll tell you. The drivers developed in embedded C language. There will be some compilers which will convert this embedded C instructions, C into assembly instructions. You might have studied compilers which will compile C language into assembly instructions. So what happens essentially, whatever drivers that are developed in embedded C gets converted, they get loaded here, then they get executed. This is how it happens. So what is the main role of these ones? They will access these registers which are present in the controller to control its behavior. You remember, go back to the bus example. What are the things through which driver was controlling the bus? Accelerator, brake, clutch, steering. So these are those things actually. This box you see, I'm telling you registers, right? Those registers is similar to that accelerator, brake, clutch, steering. By controlling them, I'm deciding how it is going to behave. Did you understood the basic concept? Finally, I want to control what it should do, when it should generate the transaction, what type of transaction it should generate. For that, how do I talk to him? It has provided registers to which it will do. See, what else bus driver could do? Assume. What is the other way to do? He can manually go and push the bus. Is it allowed? Is it supposed to be efficient? That is also possible, right? To take the bus from one place to other place, what he can do? He can go and manually push the bus. Is it possible? Not possible, right? That is where they had to make it easy for him. He's been provided with some controls: accelerator, brake, clutch, few things. Here also, whenever anything is developed, any component is developed, that component will have something called as registers. Even here, there will be registers. Even here, there will be registers. Everywhere, registers will be there. Every component you see, there will be registers. These are called as what? Configuration registers. By programming those registers, programming means simple, performing a write. You will write some value into that register. You are controlling the hardware behavior. Let's understand a simple real life example of what is meant by configuration registers. In the washing machine, you see different modes will be there. To put it in 30 minutes wash mode, 1.5 hour mode, what do? You change the knob. Essentially, when you're changing the knob in real life, what is happening is, when you're changing the knob, when you're turning the knob, some specific things are getting executed. This register is getting programmed with different values. This you can imagine like a washing machine, hardware, mechanical part of washing machine. By programming it to a different value, you make it work in a different modes. Even in your washing machine, there's a microcontroller is there actually. If you open your washing machine, see the electronic circuit, there is a microcontroller is there. There is a that my washing machine hardware will be there, right? The one which rotates, one which does the cleaning, everything. That is being controlled by my microcontroller. How does it control? There are some registers inside my hardware. By programming them to specific value, it tells this is how you should work. So this is a simple analogy that you can understand. Even if you understand washing machine functionality, this is how it will be. So have you got a feel of what is hardware and what is firmware? Hardware is the physical hardware that you are talking about. Firmware doesn't refer to any hardware at all. Firmware is the thing you have developed in which language? Embedded C. Why they use embedded C? If I give you two options to do some coding in embedded C, to do some coding in assembly code, you will always go with embedded C because it is more easy to do the coding. It's a lot easy to develop something in C language compared to embedded C. You understand that basic part? Okay. So what is the language that embedded system engineer will do? Embedded C. He develops those drivers are loaded into flash. They will be fetched. They will be executed, through which USB controller behavior can be controlled. Let's say you have got some other controller. To control that, again you have to program these registers. What value to program is provided by the drivers. It is essentially the same thing I have explained you. Okay. Okay. Why? I mean, why is it important for a VLSI engineer to know the some basics of embedded system? Basically, there are four layers. I told you, right? In electronic system, four layers are there. At what is at the bottom layer? Hardware. No, no. Applications are at the top, right? Bottom doesn't mean we wrote in the last. What is the final usage? Applications will come at the top of everything. What is at the very bottom? Hardware, right? On hardware, firmware is running. Hardware is controlled by the firmware. Firmware is controlled by the operating system. Operating system is controlled by the application. Let's again repeat. Hardware is controlled by firmware. Means how firmware controls it. It has got instructions. When those instructions are executed, some register write read happens through which we control the hardware behavior. Now how exactly it happens? You will learn it over 8 months time. You cannot. Can you learn it in 1 day time? Not possible, right? You can only get a basic idea. Then who controls the firmware? Operating system. And operating system is further controlled by applications. Okay. So since what is the upper layer of hardware? Firmware. So you should have a basic idea about what is meant by embedded system. Right? Only then you can become a VLS engineer, right? You should know what happens at the next layer. You don't need to know about operating system. You don't need to know about application. For example, you are developing a mobile phone. Let's say I am developing a mobile phone. You go to Qualcomm, you will be working on in a team who will develop mobile phone. You don't need to know how WhatsApp is going to work, because in my mobile WhatsApp will be there. As a VLS engineer, I don't need to worry about how WhatsApp will work. I don't even need to know how Android will work. But I should have an idea about how the firmware will be developed. Because as a manufacturer, let's say I'm developing a bus. I should understand what is the requirements of my driver, right? The person who is going to drive the bus. What control he should be given? How can I make it easy for him to control the bus? I mean, what can be the different design for a bus? You keep accelerator at one place, brake at some other place. Okay, you change the design completely. You make it very inconvenient for the driver. So that is wrong, right? You should develop your hardware in such a way that it's easy for the firmware engineer to control it. Only then he will be able to effectively use it. The same is, that's why you should know how embedded system engineer is going to work with me. As a VLS engineer, you need to understand how hardware works. Very deep understanding you need to have. You should have a basic understanding of what is a firmware and how firmware works with the hardware. You don't need to worry about operating system and applications. You got it right, this point. So till now we have discussed about basics of electronic systems. We understood that electronic systems has four elements: hardware, firmware, operating system and applications. And we understood how they interface with each other. And we understood what is the role of a VLS engineer. The role of VLS engineer is what? To develop the hardware. So having said that, is bus driver responsible for manufacturing of the bus? No, right? His only responsibility is what? To control the bus. But then there is a company which manufactures the bus. They are responsible for manufacturing the bus in such a way that it's easy for driver to use it. Next, let's move on to the next topic. VLSI design styles. I told you there are two design styles. What are that?
ASIC and FPGA.
ASIC and FPGA. Before we go to that, let's understand what is VLSI. VLSI stands for what? Very large scale integration. What is meant by integration? What are we integrating? What are we integrating?
Transistors.
We are integrating the transistors.
transistors.
Since we are integrating billions of transistors, for example, this mobile phone will have 100 crore transistors. How many? 100 crore transistors. Okay. So since we are integrating so many transistors, we are calling it as very large scale. Since we are integrating billions of transistors, it is called as very large scale. VLSI design styles. There are two major styles of developing VLSI chips. One is ASIC, one is FPGA. ASIC stands for application specific integrated circuits, and FPGA stands for field programmable gate array. In ASIC, what happens is the hardware is developed for specific application only, mobile phone. Let's take one example. You go to Qualcomm, let's say. In Qualcomm, there is a team which is developing mobile phone chip. Their purpose itself is to use that chip as a mobile phone chip. That chip cannot be used anywhere else. That chip cannot be used in laptop. That chip cannot be used in some other place. So let's say I have a company, I have a team. My team is only working on targeting specific application. My application is what? Mobile phone. That is called as application specific. What is application specific? You are developing a hardware specific to an application. Application can be mobile phone, application can be my laptop, application can be some kind of routers, any electronic device, right? Application can be a television, could be anything. Even a washing machine is an application. You go to, let's say, Cyprus or any company, some companies, they won't develop mobile phones. Their domain is different. They will develop hardware which is only for washing machines, microwave ovens, like that. So each company, let's say if some company targets only specific application, develop the chips only for that domain, that's called as application specific integrated circuits. What is the second category? Field programmable gate array. In field programmable gate array, what happens is the same FPGA board, FPGA is like a board, can be programmed to behave like different applications. Same FPGA board can be programmed to behave like a mobile phone, can be programmed to behave like a laptop chip. So here, programmable gate array, you are able to program it to behave like a mobile, to behave like a laptop chip. Which one is better? FPGA seems to be better, right? FPGA seems to be better because it gives me flexibility to use the same thing as mobile, laptop chip. Okay, but do you really do that in real life? You will take your chip from mobile and use it as a laptop chip? You won't do it, right? Once you manufacture it, is done. Okay, so because of that, and the other main reason is ASIC is much cheaper. Meaning ASIC, if it costs, let's say for example, 15 rupees, the same thing here will cost you 50 rupees. Almost 3 times more it will cost you. Just for comparison, it's not always rule that 1:3. It can differ, but FPGA is always more costly than FPGA. So which one looks better? As I said, though FPGA approach looks better, but industry prefers what? ASIC design flow. What is the main reason? Low cost of manufacturing. I mean, at the end, same mobile phone, if I sell at 10,000 rupees and someone else gives you similar mobile with all features same, power consumption, everything same, okay, at 20,000, which one will be by automatically? The one which comes at lower cost, right? So that is the reason why majorly companies go for ASIC style. Then your question should be, if at all that is the case, then why FPGA itself is there in the industry? There shouldn't be FPGA at all, right? There shouldn't be a FPGA term at all, because everything can be done with ASIC only, because ASIC is cheaper. But the only problem with ASIC is ASIC minimum initial cost is very high. Initial investment is very high. Means what? To do one ASIC flow, I may require, let's say, $10 million. Just an example, or $5 million. Let's take realistic number. What is $5 million? Roughly how much? 50, 45 crores is required. FPGA don't require so much money. FPGA could still be done with one fifth of the cost. Let's say it can be done in, let's say, 45 crores, right? Just for comparison, you could do it in 5 crores. Okay. But once the flow is set up, once you have set up the ASIC flow, per chip manufacturing cost is low. Understand the difference? In ASIC, initial setup process is costly. Setting up the process, you taking, understanding the requirements, developing the code, making sure that it is working, that whole process will cost more. But once it is proven, once it is know that each chip is working, manufacturing of each chip will cost you less. But in FPGA, what happens is, for you the board is already available. You can purchase the board from outside. So you are not developing from scratch. For you, there is a gate array is there. Have you studied logical gate arrays? Logic gate arrays, which can be programmed. Okay, you can program it and make it behave like the what we want. The problem here is the board itself comes costly. Each board itself comes costly for you. There, FPGA automatically gets costly. Okay. ASIC, if ASIC is cheaper, then why don't we do everything in ASIC? So the logic is simple. For ASIC, initial investment is very high. Okay, so it's like in ASIC, multi-million dollars will be the initial investment. Once the flow is working, per chip cost is less. In FPGA, initial investment is less. You, because hardware is readily there. You don't need to go through the entire process. You just develop the things, you program it as per your requirement. Since hardware is readily available, but per chip manufacturing cost is more. So it creates this kind of diagram where if your, if number of chips is required this much, you see the blue line, FPGA is better. See, FPGA is the blue line, thick blue line. ASIC is the light blue line, light color line. This is the cost axis. Y axis is what? Cost. So at this point, which one is cheaper? FPGA or ASIC? If you see, FPGA line is less smaller, right? FPGA will cost you less. So that means when your requirement is for less quantity, you go with FPGA. When the requirement is for bulk production, you go with what? ASIC. For example, here, which is better? Which is better? This is cheaper, right? What is that one? ASIC. But FPGA is costly. So what is meant by bulk production? Mobile phone, is it a limited production or bulk production? Why? What is the meaning of bulk? That cost will tell. We have to sit and do the equations. Means they will sit and do the equation. What is my initial cost? What is the per chip cost? Okay. In FPGA, what is my initial cost? What is per chip cost? There they will come up with a break-even number. They'll come up with a number where they know this is the point where till this point FPGA is better option. Beyond that, if I want to do, I have to go with ASIC. So in summary, if I have to develop a chip, I will have idea, right? Do I want to develop a mobile phone? I want to develop a laptop, or I want to develop some consumer electronic product, oven, washing machine, heater, anything, right? Everything is involved in, has electronics inside it. I will decide what, let's say, or I want to develop some application, some electronic product for colleges, educational institutions, or some electronic product for flight, aeroplanes. I will see what is the market. Will it have requirement of thousands or lakhs or millions? How many chips I have to manufacture? Based on that, I will get to know number. Let's say I only want to manufacture 1,000 because let's say I'm targeting something for flights, aeroplanes, right? There will be hardly thousands of flights only gets manufactured, right? Not lakhs, right? So given that, I will choose FPGA for that because overall for me FPGA will be cheaper compared to ASIC. But same thing, if my target domain is a mobile phone, I'll always go with ASIC. This is how they decide. But both will help you develop the required thing. Okay. ASIC versus FPGA. Any VLSI chip can be developed either with ASIC or FPGA flow. Decision is based on the cost. Let's say example is what ASIC based flow, it will cost $15. I have given you example, right? Where you need bulk production, you go with what? ASIC. Bulk production, you go with ASIC. Limited applications, you go with FPGA. So given that you see 85% of the market is for bulk usage, so that's done with ASIC. 15% of the chips will be done with FPGA. That number 15% is not like a fixed number. 15 to 20%. This I can call 80 to 85%. Let's now understand what are the advantages of ASIC over FPGA. Someone is playing. I see the same. My voice is echoing. Those attending online, please be in mute. Let's understand the advantage of ASIC over FPGA. FPGA also has some advantages. ASIC advantages. First thing is it is cheaper. Manufacturing cost. Once you go for bulk production, it is cheaper. It consumes less die area. It's to manufacture the same functionality because you are doing yourself. I mean, you are customizing your requirement rather than purchasing something and doing on that. You are developing your own thing. So you will be able to develop it better. So it will be cheaper. That's why it becomes cheaper. Provides flexibility to customize the features. I mean, since you are developing from scratch, you can customize it the way you want. It is power efficient. Power wise, it is better. Okay. And it most importantly, it can work at higher frequencies compared to FPGA, hence gives better performance. These are the advantages of ASIC over FPGA. Next, let's understand advantages of FPGA over ASIC. So one main advantage is the quick turnaround time. I mean, you can come out with the chip quickly. That is one thing because you don't have to start from scratch. The second major advantage is respin cost is very less. Cost of respin. What is meant by respin? Tell me. It's like if you have developed a chip development starts from where? Requirements till packaging. Respin means in VLSI terminology, respin means doing the entire process again is called as respin. Doing the entire process again is called as respin. In ASIC, the respin cost is very high because you have to again do lot of things from scratch. The whole process need to be developed again from scratch. Whereas in FPGA, it is very cheap. It is because if one chip is not working, you have to throw it out, use a new chip and implement logic on the new chip. So there it becomes very easy. So thing is what if the chip has a bug which is detected after manufacturing, FPGA style doesn't incur. big cost. Whereas ASIC will involve lot of cost actually. We don't have to implement the entire flow again. Bug can be fixed in the another FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we need to do the entire flow. That is called as respin. Okay, you can just go and search in VLSI what is meant by respin. You will get to know VLSI respin. Bug has to be analyzed. ASIC has to go through, meaning it has to be built again. The entire flow has to be built again. The overall thing, where is the mistake happened, that has to be fixed, and you have to redo the entire thing again. Okay. The simplest example is like, for example, there is a house constructed. Some structural damage is there, structural mistake is there, which you cannot fix. You have to redo the whole building again. Understood, right? Some structural mistake is there where you cannot do anything. You have to construct the whole building again, starting from the foundation. Whereas in FPGA, it's not like that. Your structure could be modified. It gives you option to your that structure doesn't cost you much. You take a new structure and you check it on the new structure. FPGA flow is quick. Since we don't start from scratch, the board is readily available. It takes less time to develop FPGA compared to ASIC. In fact, FPGA, actually even FPGAs are used in the ASIC flow. In the ASIC flow, there is a term called as FPGA prototyping. What is FPGA prototyping is, before you actually go for ASIC fabrication, you check your behavior with FPGA board. Whatever you are developing, you check that board behavior using FPGA. Only once it works, then you go for production. What is FPGA prototyping means? Implement the ASIC logic on the FPGA board and check the behavior. And if there are any issues, you fix those issues. Only once you prove that it is working on FPGA board, then you go for bulk production. You got the basic idea, right? What is ASIC and what is FPGA? ASIC versus FPGA. I think this we have already discussed. We have discussed this. Okay. So let's summarize everything that we have discussed so far. So we discussed about electronic system. Then we started with what? VLSI design styles. How many VLSI design styles are there? Two. One is ASIC, one is FPGA. Okay. ASIC is what? Application specific integrated circuit. FPGA is field programmable gate array. In a simple, at very basic level, any company who wants to develop chips, they will decide, they will do the market study, figure out how many, what is the chance of how many chips may be sold. Let's say I analyze this one, I may sell that, I may come out to the conclusion that I will be able to sell 1 million phones. So I will have to manufacture how many chips? 1 million. So 1 million means what? I'll go with ASIC. Let's say somewhere else I analyze that I will be only able to sell 5,000 chips. So I'll go with what? FPGA. Now, how do you really come up with that number? Where what is the threshold number? You have to do the calculations actually. You have to do the calculation. Based on that, you decide whether to go with ASIC or FPGA. ASIC has some advantages, FPGA has some advantages, but lot of advantages are there with ASIC. Next, how does VLSI flow differ between ASIC and FPGA? I mean, if you take ASIC and FPGA, how does that flow differ? The front-end domain flow, the front-end domain flow is similar between for both ASIC and FPGA. If you take ASIC and FPGA, front-end domain flow is similar. In both the cases, user needs to understand the design specification, implement the design using Verilog and VHDL languages, functional verification using SV and UVM. Okay, that means this flow is same for both ASIC and FPGA. Means there won't be much difference in the front end domain flow. So where does majorly differ? Where do they differ majorly? Majorly they differ in the backend domain flow. Backend domain flow means what? The flow starting from physical design to layout. Means ASIC will have a different style of doing it. FPGA will have a different style of doing this thing. What are the steps? Physical design to custom layout will have different ways of doing it. The way we do floor planning, placement, power planning, CTS, routing, IR drop analysis will be different in ASIC and FPGA. All these steps differ. Did you get a basic idea? So in summary, the front end domain flow is similar. Back end domain flow is what differs. This was about ASIC versus FPGA. Okay. Now let us talk about ASIC design flow. This demo session will be more focused on ASIC. If at all any of you want to get into FPGA domain flow, there will be another demo session for FPGA separately. Okay, where the trainer will only focus on what is FPGA board, what features will be there in a board. Like you would have heard Xilinx Spartan boards. Have you heard any time? Xilinx boards will come, Altera boards will come, FPGA boards will come. Those boards are readily available. I can purchase the boards and I can implement my logic, and that will start behaving like my required hardware actually. I can program those boards to behave to get a required behavior. Okay. So that FPGA trainer will give you that overview. Okay. And he will also give you a brief about how the backend flow is implemented, the floor planning, power planning, everything. How it is done in the FPGA board, he will touch upon those aspects. Now for remaining part of the session, let's only focus on ASIC design flow. So this is the third aspect of our demo session. First aspect was to understand electronic systems. Second was to understand ASIC and FPGA. Now let us go deep into ASIC design flow. ASIC design flow is similar to a house construction flow. You can understand ASIC design flow by understanding how house construction happens. Tell me how do you where do you start? How do you start house construction? You want to construct a house. How do you start? Tell me. First you go for what? Planning. You have to go for planning, right? I mean, you have to figure out what is your requirements, right? How big house you want, how many floors you want, right? First you start with what? Requirements. You list down your requirements. Once your requirements, whom do you go to? Requirements is like what kind of house, everything, right? Then whom do you go to? Architect. You will go to architect. You won't sit and draw the architecture, because do you have that expertise to do that calculations of the everything? No. You'll go to architect. What architect will do? He will understand your requirements. The previous stage becomes the input to the next stage. Your requirements are inputs to the architect. What architect will give you? What he will give you? He will give you architecture diagram, various plans, different plans he will give you. Then whom do you go to? Some contractor or mestri. What for him these are the inputs. You go to a contractor, you will ask, do you have an architecture diagram, do you have these various plans? Okay. What he will do? He will build the building structure. Means given the inputs, he will develop the entire structure. What then? You have various people involved. So idea is, I'm not trying to teach you the house construction, I'm trying to tell you that chip design is also very similar to that, very similar to it. Okay. How much similar we'll discuss. Okay. In the so here, can whole house construction be done only with one person? Is it possible? You have to have different types of people. Architect is required. Without architect, can we construct a proper house? No. Without mestri, labor, plumber, electrician, carpenter, everyone is required, right? Only then you have a proper house. Okay. So you can, one more thing, can I ask plumber to do electrician work? Vice versa, it's not possible, right? Same way in VLSI also, different engineers come with different expertise. Let's say plumber expertise is what? Plumbing. He is very good at doing the water pipe connections and everything. Carpenter, he is very good at doing the carpentry related. He don't have other expertise. Same way in VLSI also, someone who is into functional verification will have functional verification expertise. He cannot do physical design. He cannot do DFT. Okay. Let's say I am constructing a house. Will I hire a person who is very good at plumbing, or will I hire a person who knows little bit of everything? Will I hire, I mean, if I'm looking, I'm building a team. My work is what? To get one house construction done. Okay. I want to hire some different people. Will I hire a person who is very good at plumbing, or will I hire a person who knows little bit about requirements, little bit about architecture, little bit about contracting work? Whom will I hire? Very good in one thing. I'll hire one person who is very good in one thing, because if he knows little bit of that, how he can do everything properly. So industry also, you can think of this also like a company. Like I am hiring people, so next whom I will hire? A very good contractor, sorry, carpenter, a very good electrician. So my, what is my company does? My company is responsible for manufacturing house construction. My company is responsible for house construction. I won't hire people who knows little bit of everything. I'll hire people who are good at, very good at one thing, only one thing, but they should be expert in one thing. Okay, next. If I want to decide paying to a carpenter, how do I pay him? How do I decide to pay? How much to pay? Based on his workmanship, right? How, what is the quality of his finishing, right? All that. Same thing, exactly the same thing you can correlate to VLSI also. Okay. Will I pay him because he just comes and sits and goes? Finally, you pay him only when he does something productive also, productive, right? He should show some expertise which other people cannot easily do. The same thing applies to VLSI also. In VLSI also, companies will hire you because you are expert in one domain, only one domain, but you should be expert. Okay, first thing. Second thing is your salary, growth, everything depends upon what? Your expertise, right? You will find people. Yesterday I met one person. Okay, not exactly into VLSI, but he works into firmware development. I mean, he was one of our trainer earlier, but then he, in embedded we wanted to pursue. His experience is 7.5 years. Okay, he almost gets, okay, 1 crore. Okay, so a point I am trying to tell is, it's about, it all comes down to the expertise. Industry works in a very irrational manner. It's not like you are 40 years old, you will get this much salary. It's not the age factor that matters. It, what matters is the expertise. He has so much expertise that he gets that level of salaries. So it is possible. All you have to develop is a passion. See, if I was pursuing house construction, let's say as a carpenter, I have to do everything, the techniques. I have to passionately learn carpentry work to extent where I'm able to make, develop the do the carpentry work where I impress the other person. Same way in VLSI also, you have to choose one domain which is interesting for you, and you have to become expert in that domain. Okay. So same, the similar to house construction flow, ASIC design flow can be divided into two major categories. One is front end domain, one is back end domain. See, even in house construction, there are two major steps. One is till the time that building structure is developed. Till the time building structure is developed, right? Second is what? After that, everything. After that, only you do carpentry, tiles, electrician work, plumbing, everything. So, something similar to that. Okay. Front end domain starts with what? Requirements. Then you go to whom? Sure. Then you go to a design person who will develop the design. Okay. Then you integrate. Small blocks are developed, integrated. Then you do the verification. Whether the design is working or not, properly or not, you do the verification. Then you do design for testability at the Verilog RTL level. You do the design for testability at the Verilog RTL level. Okay. So you understood what all steps are involved in front end domain. See, majorly front end domain is these steps, which is programming oriented. I mean, you need programming expertise when you want to get into design, integration, and verification. You need programming expertise. Backend domain starts with a step called as synthesis. In synthesis, what we do is whatever RTL code, RTL stands for what? Register transfer level. It is one style of coding in Verilog. It is one style of coding in Verilog. Converting that RTL level into gate level format. You will get it as AND gate, OR gate, something like that. If you are very new to Verilog also, don't worry, we'll teach everything from scratch. Here I'm just trying to give you a top level idea. So backend domain starts with what? Synthesis. After synthesis, what is the next step? DFT. Then physical design, static timing analysis, custom layout, physical verification. Then finally, once you do physical verification, you have graphic design system. I mean, GDS2 file will be extracted. So after all these steps, what do? You extract one file called as GDS2 file. It's similar. You can think of it like a, after all the film production, they will generate one MP4 file. Movie file, right? Movie I'm talking about. And that you can play and watch, right? Same thing happens. After all the, that entire information is captured into one file called as what? GDS2 file. GDS2 stands for what? Graphic Design System. Now, what exactly is GDS? Let's not get into it. It's a, in simple terms, it will tell where the silicon should be there, where the metal should be deposited, where the etching should be done, where oxidation should be done, how much depth it should be done. That is what that file will tell in a very simple terms. See, for fabrication, that's what they need, right? If this is a silicon, sorry, this is my silicon, where the metal should be deposited, where the oxidation should be done, where the polysilicon should be deposited, how much doping should be done, should it be n plus doping or p doping, they will all decide. That is what this GDS file will tell exactly. So when I give this file to the foundry, there will be TSMC. Okay, there are different foundries, right? When I give to them, they will do the fabrication. Once the fabrication is done, we check the chip will come, we will check whether chip is working fine or not. That is called as what? Post silicon validation. Finally, once you prove that chip is fine, then you go for what? Packaging. When you do packaging, you get finally this product. So in summary, any electronic product you are using, let's assume, let's take the mobile phone case only. Before it came into your hand, okay, it got packaged, right? It was packaged and it is given in the packaged format. It went through so many steps. Very first, probably 2 3 years back, back in 2022 or 2021, they would have started requirements. They would have started off with what? Requirement. They would have understood what kind of mobile phone was required, what should be the processor, what should be the display, okay, what should be the charging port, everything they would have displayed. And because they know that they are going to target, what is the target customers, am I going to target customers who is in the 5000, below 5000 range, or below 10,000 range, below 20,000 range, or below 30,000 range? Accordingly they'll come up with the features. Even when house construction you do, you decide, right, what is your target customer. Am I going to target someone who is going to purchase below 50 lakhs, below 1 crore, below 2 crores? Same way they'll do the planning also, architecture planning. Then they go through different stages till they reach here. This is majorly divided into two steps. What is the first step? Front end domain, back end domain. This is majorly important for training institute because when a student comes, they have one requirement: I'm not good at programming, or I'm okay with programming. This is mostly relevant for people who are comfortable with programming. Even if you don't know programming today, but if you have interest in learning programming, this is suitable. Whereas this domain doesn't have any programming at all. No programming in synthesis, DFT, physical design, STA, custom layout, no programming at all. It is only expertise with the tool and technology. The backend domain only involves what? Expertise with tool and technology. Let's understand what is meant by technology. What do you mean by technology? You would have understood the technology, right? 14 nanometer technology. Right now chips are manufactured at what technology? 5 nanometers. The the finfets which are going into the chip, okay, the transistors that are going to the chip are what? Finfets. Okay, their channel length is only 5 nanometers now. The distance between drain and source is only 5 nanometers. As that comes down, the chip cost will come down because the area taken by each chip will be, each transistor will be less, because of the chip cost will be lesser. That is how they are able to reduce the cost of production. Got it, right? Now when you go to lower technology, there will be problems. As you reduce the thing, the more some different problems will come. What we call as short channel effects. Okay, so you need to understand those level of technology concepts. I mean, what problems do we face in BJT? What problems we face in CMOS? What is CMOS? Complementary MOS. Complementary MOS will have some problem called as latch up problem. CMOS latch up. When we go to FinFET, there will be some problems. I mean, there will be some problems like short channel effects. Okay. So what are these things? Is what these people will mostly be focused on. And that you understand what is technology means how the capacitor charging will happen, discharge will happen, how the voltage drop will happen, is what backend engineers will be concerned about. What is meant by tool expertise? There will be some softwares involved, like you might have used some cadence or synopsis tools in your college, right? What tools have you used? Xilinx. Okay, some tools you would have used. This is mostly tool oriented job because in backend, I'll just to give you a feel of what is physical design. We are trying to place, let's say, assume, simple example I'll give you, assume this is my table, okay, on which I am trying to place, arrange 10 items I have in my table. Laptop is there, mobile is there, remote is there, I'm trying to arrange. How do I arrange 10 things? Something like this. This is about arranging how many? 10 things. What if I have to arrange 100 crore transistors in a small area? How many transistors we have to arrange? 100 crore transistors in a very small area. How much area? 1 centimeter this side, 1 centimeter this side. Your area of your chip is how much? 1 centimeter both sides, even smaller, actually smaller than that. When you are trying to arrange in that much area, what will happen? It will be very challenging, right? Can you do manually? No, you have to use some tools, some softwares to do that work. You have to instruct the software that try this option, try this, then they will do that. You understood, right? Yeah. I understood, right? So in summary, what I'm trying to tell is I'm not expecting you to learn what is physical design, what is DFT, everything. I'm trying to help you understand what is the difference between front end domain, back end domain. Front end domain requires what kind of expertise? Programming expertise. It is a lot towards programming, developing the code, understanding the behavior, developing the code. Backend domain is more towards knowing the tools and technology. What is meant by tools, what is meant by technology, our course will teach you. Because can I teach everything in 1 hour? No, right? Is it possible to understand everything in 1 hour? No. So that will be done over a period of time in a gradual manner. Okay. But then why it is important for you to start deciding which domain I should get into? You should decide, am I more inclined towards programming kind of job, or am I more inclined towards technology based job, tool and technology based job? Accordingly, you can choose. Both the domains will have good opportunities. I mean, it's not like one domain is good, one domain is bad. Everyone will have their own opportunities. Okay. So let's go for a short break. Okay, let's meet at 11:10. Another 12 minutes we'll meet. Then we'll have a session for maybe 1 hour, and then we'll wind up.
This conference will now be recorded.
So we majorly discuss three things. First thing is about understanding of electronic systems. Then we discussed about VLSI design styles, ASIC and FPGA. Then we discussed about the ASIC design flow. Okay. So what is the important takeaway from ASIC design flow? You should not try to learn everything. Okay. You should choose one particular domain and because become expert in that domain. So what is the advantage we will give as an institute, VLSI Guru Institute will give you is, we'll give you 2 months time to choose what is interesting for you. Let's say even if you choose today, let's say some of you have chosen DFT, let's say some of you may choose verification. We'll give you 2 months time. Till the time, if you like that domain, you pursue that domain. If you don't like that domain for any reason, means it could be because technically, or it could be because of job opportunities or whatever, we'll give you option to switch to other domain with no additional cost. Then you may say, what about the 2 months I'm going to lose? 2 months you won't lose. Initial 1 month is common for everyone. Whatever domain you do, DFT, PD, DV, FPG, any domain you do, 1 month is always common. The second month is different. That second month you will not lose because you will join into the next batch. Let's say you're joining January batch. When you want to move to a different batch, you will add into February batch. That way, there 1 month would have completed. There you will start. That way, you don't lose anything. You would have done 1 month of additional training in some other domain. So that is the advantage we will give you, so that you won't be stuck with something. Let's say you chose something today. After 2 months, you don't like it for any reason. You won't be stuck with it. You'll be able to switch to the other domain. Okay. Second thing, I'll come to the technical part. Training, yeah, training, getting job training is 70-80% is in the student hands only. Institute only helps you up to 30%. What is institute role is to provide you the good training. I mean, where subject is taught properly to you, assignments are given, projects are done and shown to you, and institute will try to make you do the things. That 70% you have to do. What is mean by that? You have to find a passion to develop, to do it. I mean, you have to learn it with a passion rather than job as a target. You should be developing a passion towards one subject. I mean, I should become expert in DFT domain, I should become expert in physical design domain. Okay, essentially developing expertise doesn't involve a lot of things. Some concepts will be there. For example, I'm studying inter, physics is there. How do I become expert in physics? There are 50 theorems are there. Hardly. If I put together all mechanics, kinematics, everything, right? Rotational mechanics, everything put together, there are only hardly 50 theorems are there. Each theorem I have to learn properly, understand what are the equations involved, then I should be able to apply. Something similar here also. When you get into DFT, there will be hardly 50 concepts will be there. 50 to 100 concepts will be there. In PD also, physical design also, from 50 to 100 concepts will be there. Those concepts you have to learn in depth with proper research and everything. Our trainer will teach you that. But from your side, you have to do the required homework. Okay. So let's summarize this part. Means you have to choose one domain which is interesting for you. You should prepare not keeping the job in mind. Your target should not be job initially to start with. Your target should be to work with passion to become expert in that domain. Right? When you have that expertise, people will respect you actually. I mean, I go to my building construction, let's say, I see a carpenter is doing a beautiful work. Automatically respect will come. When I give a lot of respect because he's doing a very beautiful work. Someone who is doing a bad work, I'll abuse him. I'll not treat him properly because he's not doing a good work. So that when you does some work with passion, automatically you get everything. You get the good job, salary, everything automatically comes. So you have to develop what? Passion towards learning something. Passion cannot, institute cannot infuse that passion. Can I infuse passion into you? No, you have to develop that passion to become expert in something. That passion has to show in what you do, how you do the things. Okay. But what institute does is, institute will make sure that you are given right guidance at every stage, right materials, right set of exercises, right projects, skill set, everything is given. Rest you have to take care. Okay. Next, let's briefly talk about front end domain flow. The front end domain flow is similar to a software flow. What does it mean by that is, what is the skill set required for a software engineer? Languages like C, C++, and Java. What else you require? They should be good at reading the specifications, software specifications, and develop algorithms and implement the same using C, C++, or Java. Means they should understand the problem, they should develop an algorithm, implement the algorithm using what? Different languages, C, C++, or Java kind of languages. They should be having good programming skills, right? Only then you can become a good software engineer. What about a VLSI front end domain engineer? I'm talking about, it could be RTL design engineer, integration engineer, or the verification engineer. Three domains I discussed: RTL design, integration, and verification. Similar to Verilog, we have a language called Verilog. Similar to C++, system Verilog. Similar to Java, UVM. Like in software, C is there, C++, Java. Here we have what? Verilog, SV, UVM. Someone who want to get into front end domain should be good with programming, or at least inclination towards learning programming. You may not know programming today, but you should have that interest. Okay, I can learn. That interest should be there. You should be good at reading the hardware design specifications and understand the functionality. I mean, what is the specification, how the hardware will behave, that interest should be there. Implement requirements using protocols. What are the protocols? USB protocol, PCI Express protocol, DDR protocol, AMBA protocols, SPI protocols. So this is the kind of skill set that is required for front end engineer. This is what is required for software engineer. You see, there is some similarity between them. They are not
Hi,
same.
I have one
Yeah,
question.
yeah,
So this reading hardware design description, is this covered in the course? Like, do you discuss this?
yeah, yeah. We are going to discuss this. We are
Okay,
going
okay,
to
thank you.
discuss this basically at one stage of the course. I'll show you that syllabus also there. So this is the course we are talking about. Front end course or functional verification course. We'll have one industry standard project called as Ethernet MAC core functional verification. It starts with reading of the design specification. We will teach how to read the specification, how to understand architecture, how to look at the sub blocks, how to understand interfaces, how to understand registers, how to list down features and scenarios, how to develop the test plan. That entire flow will be taught till the time we do coverage analysis and everything. Covered. Okay. So what is the purpose of this slide is to tell you that if you want to get into front end domain, your work will be somewhat similar to software engineer kind of work. Reading some document, understanding the document, implement that behavior using Verilog language. In some verification engineer will use languages like SV and UVM to do the verification. Do you think does it require any technology expertise, knowing FinFET and CMOS and all that? No. Does it require any kind of basic expertise like current and resistance, everything? No. So you see, front end domain work is more close to a programming kind of work. Okay. So where does VLSI differ from software? Backend domain, right? Software doesn't require backend flow. Why? Let's understand. What is backend domain flow means? Process of converting the Verilog RTL code into a chip. Means once you have the Verilog code, which is finally you manufacture a chip, right? That entire process is called as what? Backend domain. Means you have developed some code and you have verified that that code is working fine. Will you go and buy that code and use it as a phone? No, right? Finally, what will you buy? Some physical design, physical chip, right? Phone. So that process of converting that Verilog code into a chip, that entire process is called as what? Backend domain flow. Here in software, there is no backend domain. In software, what happens? Once you develop an application, do you manufacture into a chip? No, right? You directly use it on your laptop itself. Let's say I have one Windows Office is there. Do I buy it as a chip or do I get it as a code application and I use it? So in software, there is no concept of backend domain. I mean, at least the manufacturing is not there. In software, the code is installed and used. No need to manufacture as a chip. In VLSI, functional verification plays a very important role. If there is a bug in the chip, let's say some bug is in the chip, which is detected once it is in production. Means once the chip is manufactured, you find a bug. Okay, that is the one customer is using. Bug can't be fixed. The entire flow needs to be done again. VLSI chips don't have a concept of patch. In software, what happens? They will release a patch. Let's say you're using your office, Windows Office, there is some bug in the office where font is not taking effect. Means what happens? Somewhere I'm using a specific font and that font is not working. They don't have to redo the entire thing again. They'll just release a patch. When I use the patch, my office will get fixed. In software, if there is a bug, it can be fixed easily, can be released as a new version of the software as a patch. They'll give it as a software patch, and that you patch you use, it will fix it. So do you understand majorly where software and VLSI differs? Do you understand why functional verification is very important? Because if there is a bug, you will have to do the entire flow again. In software, even if software has some bug, you don't have to do the entire flow again. You have to release a patch and fix that. Next, the fifth aspect of the today's session, VLSI domain and different job roles. I told you, right, there are different people in the VLSI. For each one, there is a specific person. For design requirements, there is a person called as marketing team. For architecture, chip architect. For RTL coding, RTL design engineer. For RTL integration, RTL integration engineer. For functional verification, functional verification engineer. Like that, if you see, there are almost 14 to 15 people involved in this entire. It's
Uh,
yeah.
I have one question.
Yeah, please ask.
So in this RTL design engineer and functional verification engineer, so what's the difference? Like skill wise, what's the major difference?
See, the skill wise, RTL design engineer has to have a very in-depth understanding of the design. He will develop a code which can be converted into gates, which needs to be synthesized. Whereas a verification engineer responsibility is to develop a test bench. See, if this is my design, let's say the blue box is my design, the verification engineer role is to develop a test bench around this, okay, around the design, and he applies some inputs, he gets some outputs, he checks whether this output is coming as per the expectation. This is the first thing about what is functional verification. Let me brief again, I think it was fast. Design engineer responsibility is to develop the design using Verilog language. Finally, this need to be converted into a chip, because the whole purpose of developing design is what you want to use it as a chip, right? Finally, as a mobile phone or as a laptop. Whereas the person who is developing on this test bench, checking everything, that red boxes won't convert to chip. They're only for testing purpose. So his approach will be little different. Okay, the role of a verification engineer is differs where you apply inputs to the design such a way that you check if there is any mistakes in the design, you are trying to catch those mistakes. As a verification engineer, I am trying to catch if there are any mistakes done in the design. For that, I develop something called as test bench. TB stands for what? Test bench. Through the test bench, I apply some inputs. When I apply inputs, what will come? Some output will come. I have my own model called as reference model, which will give me expected output. I compare with this actual output and expected output and then confirm whether it is working fine or not. Did you understood? Okay. Now from the
Yeah, so
approach wise,
just one more thing. So
yeah.
if someone is working in the field of functional verification and later he wants to switch to RTL design, how can one do that? Like, what else do you need to know for that?
He first thing is he needs to look at the things from a synthesizable perspective. See, when I develop this test bench, whatever you see in the red box, I don't bother whether it can be converted into gates or not. I will develop because I have no requirement to convert it into gates. Whereas anything that is developed in this blue box needs to be converted into gates. It should be synthesizable. So I have to look from a perspective how to develop a code which is synthesizable. So a synthesizable code has some specific coding requirements, that you have to use always blocks, you have to use non-blocking statements, some guidelines will be there, which we will be learning as part of our Verilog course. When we do our Verilog course, we will be learning some guidelines, standard guidelines that you have to follow when you develop your design. So having a proper understanding of design and knowing Verilog language, you will be able to develop, you will be able to switch from verification role to design role.
Got it. Got it. Thank you.
Sir, I have a question.
One thing, you also need to have a good understanding of the state machines, FSM. You might have studied Mealy state machine, Moore state machine, how to implement that expertise is also required. Please ask.
Sir, my question is, we have DFT at RTL level and also at gate level. So if we choose the DFT course, do we have to learn those two things also, or we have to choose only one of them?
No, both will be taught to you.
Okay, so like even in the job also, will you have any specific
Yes, both.
topics to
Yes,
work?
yes. Let me explain you what is DFT briefly.
Okay.
Tell me, what is your understanding of DFT?
Like it is a testing of some with some patterns.
Yes, okay, testing of something with patterns. Let's understand why DFT is required. Okay, by now you would have understand that testing is a very important thing in VLSI, more important than software. Why? In software, assume I'm using this, there's some bug here, let's say list make doesn't work. So this feature what you see, one of the features in this software doesn't work, let's say. What this company, whoever releases this software, they'll release a patch. When I take that patch, that bug will get fixed. You understand, right? Whereas in hardware, my mobile phone has a bug. For example, my mobile phone has a bug, it cannot be fixed. I have to buy a new mobile phone only, because some bug inside the chip, there is no way to fix it. So because of that, testing and verification is very important in VLSI flow. Testing or verification and validation are very important in VLSI flow. At every stage, they will do the testing. You know, different types of testing they do. They will do functional verification. They will do timing verification. They will do physical verification. They will do power aware verification, power verification. They will do IR drop checks. The point is, in VLSI flow, verification has a very important role. At every stage, we keep checking. At every stage, because you want to make sure that you don't miss anything. If you some bug is missed, something is missed, it will finally come into product. Once it has come into this product, manufactured product, you cannot do anything. You have to go for what? Respin. The respin will cost the same amount. Let's say you are constructing a building. Let's say already you spent 1 crore rupees. Some structural defect is there. Can you take something from that 1 crore and do it? Nothing. That whole 1 crore is gone, right? You have to start again from the scratch. The same problem happens in the hardware. In software, that won't happen. In software, you can do a small fix and make the same thing work. That's why verification plays a very important role. Okay. There is something in VLSI flow called as post silicon validation, which is used for also used for checking manufacturing defects. What is it used for? checking any manufacturing defects. Now, why manufacturing defects will happen? When chip is manufactured at 5 nanometer technology node. You know what is 5 nanometer, right? You can imagine very small thing. I mean, you might have seen the measurement scale in the millimeters will be there. That millimeter gap you divide into how many times further? 1 by 10 lakhs. That millimeter gap you divide into how much? 10 million parts. You can think of how small is it, right? Just to imagine how small it is. There, even if a small dust particle, how much small dust particle you will see in the air, in the sunlight, if you go, small dust particles will be there, right? That dust particle will be much bigger than nanometer. That's why you're able to see with the naked eye, right? If you go to the sunlight, you will see some small particles going in the air. Even into the chip, one dust particle goes. That small dust particle, the chip will not work. I'm telling there are different reasons why one chip may work, one chip may not work. The company, let's say TSMC is there, they'll develop a process in such a way that that doesn't happen. Dust particles don't go. But still, whatever they do, out of 100 chips, some chips will fail definitely. Okay. Why they will fail? Mostly because of manufacturing defects. So manufacturing defects are few types. Chip can have manufacturing defects. They're called as stuck-at faults, some at speed faults. I mean something the DFT trainer will tell you. Okay. These faults, I mean idea is to, you have to identify, right? Once the chip is manufactured, let's say 100 chips are manufactured, assume, you should identify which are good, which are defective, which chips are good, which chips are defective. You need a techniques to do that. The DFT engineer develops some vectors, some testing patterns. If you ask me what is pattern, is some kind of example of patterns is like 10, something like this. Just to give you an example, okay? Now you may say, what is there 1010? It is not random. They would have some meaning. The numbering has some meaning. This pattern, when applied to the chip, output will tell me, is everything good? Is there any defect? It will tell me, the output pattern will tell me like this. The role of a DFT engineer is to develop such patterns. Will they do randomly? Is it like throwing a dice and getting 1010? No. They will have some techniques. DFT engineer uses some techniques. Some DFT techniques. What are those DFT techniques? Scan insertion, okay, automatic test pattern generation, built-in self-test, uh, the compression. I mean, though they may not be directly related to the testing pattern generation, I'm just giving you some example. Compression, okay, JTAG, boundary scan. Effectively, by doing all this, they're making sure that if a chip has a manufacturing defect, they should be able to catch it. Okay. When will I call someone a bad DFT engineer? When will I call someone bad DFT engineer? He has developed a pattern which is not able to detect the manufacturing defects. Let's say chip is manufactured. His patterns are not able to tell which chips are good, which chips are defective. Then he's a bad work, right? So what is a good DFT engineer does? He develops a patterns which when applied will tell me whether this chip is good this chip is defective. Now, in 1 hour, we cannot learn what is scan insertion, what is ATPG, what is BIST. Over a period of time, the trainer will teach you what is scan, what is ATPG, how the tools are used. I mean, is it randomly done? Is it some technique is there? Some concepts will be there. How do you do scan insertion? How do you do test pattern generation? How do you do built-in self-test? BIST is what? Built-in self-test. How it is done? What is the concept? All that will be covered. So finally, your role is what as a DFT engineer? You use these techniques, you develop testing patterns. These patterns are given to whom? Post silicon validation engineer. Give to whom? There is one more engineer called as post silicon validation engineer. His role is simple. He will get 100 chips. He has to apply these patterns and tell it is working, it's not working. If there is some defect, why there is a defect? If there is some defect, what is not working? He has to tell all that. That is the role of a post silicon validation engineer. Is he responsible for developing the patterns? No. Who is responsible for giving the patterns? DFT engineer. Like that. If you take any team, ASIC team, let's say you get into one mobile SoC project. Around 25 to 30 people work into the front end domain. Around 20 to 25 will work into back end domain. And little more people, 10% more people into the front end domain. Even in that, tell me which domain has more people? Functional verification, physical design. Functional verification has how many people working in a team? 30 to 40%. Physical design has 20 to 30% of people. DFT has around 2 to 5 people. Design team has only 4 to 6 people. I mean, this probably gives you an idea of how much importance is given to the verification. Verification is given a lot of importance in a company because you want to make sure that your chip don't have any bugs. You may say, how can you work with such a less people? I mean, how can we work with only 4 to 5 people designing whole designing work? Because it is possible because companies buy the IPs. Let's say if I want to develop something, let's say construct a house. I don't I don't grow a tree and then make a wood out of it. What do? I go and buy the wood frames already. Okay, I don't start the process of making steel. I'll go and buy the steel. So same way companies also, they don't do everything. They'll buy the IPs, processor from one company, USB from one company, DDR from one company. Then they assemble everything. Because of that, they don't need many people actually. With less people itself, same work can be done. But verification still requires more people. Okay. Now, you may say there are less people for DFT. How can we get job? See, then naturally what happens is there will be more people enrolling to functional verification and physical design, less people in DFT domain. Just to give you an example, if in functional verification, let's say we train around 350 people in a year, for example, DFT we will only train around 100 people, around 100 people, plus or minus something. Physical design also we train around 300 people. Naturally, the distribution happens. I mean, because there's a less requirements, less people join training. So, in summary, every domain has similar chance of getting job. The domain where you have more opportunities, more people will take the course. Domain where there are less opportunities, less number of requirements, there will be less number of people undergoing the training. It all comes down to becoming expert in the subject. When you choose any domain, you choose verification, you choose DFT, you choose physical design, you become expert in that domain. Okay. Once you develop that passion, okay, you can get job easily. Okay. Okay. I had given you, having said all this, okay, we are giving you the flexibility to switch. Let's say you chose something, you can always switch the domains. Okay. DFT overview I have given you. Okay. uh, DFT engineer, what does they do? They develop test patterns which help detect the manufacturing defects in the chip. A sample pattern could be something. This pattern is applied to the chip. Chip output tells whether the chip is good or faulty. DFT engineer uses various techniques to generate the above test pattern. Scan, ATPG, BIST, different patterns are there. Okay. I have also already told you what does a post silicon validation engineer does. Takes the test patterns from DFT engineer, applies them to the chip, verifies the chip behavior. In VLSI manufacturing, there is a term called as yield. Yield means what? If I manufacture 100 chips, if 95 chips are good, then I got 95% yield. Yield means what? How much productivity you got, right? Because 5% are defective, you have to throw away. So that 95% is the yield. If 100 chips manufactured, 82 chips are working fine. Then what is the yield? 82%. So this is a very brief about different domains in VLSI: front end domain, back end domain. What skill set front end domain requires? Majorly inclined towards programming, reading a document, understanding the document, learning some languages like Verilog, System Verilog, and UVM, and doing the verification. Back end domain don't need any programming. It is more technology focused job, tool and technology focused job. Now, what is tool? How we use tool? We'll teach in the training. Next, let's go into training schedule. That was a bit about uh, what do you say, the domains and everything. Now let's talk about training schedule. Mode of training. The training is available in full week mode, weekends only mode. Sometimes, based on the availability of students, we may even do weekday evening batches also, possibly. But these two will be there. Full week and weekends is always there. I mean, full week is suggested for freshers who are not currently working. Weekend is mostly for the working professionals. Full week is available in online. If you want to do 100% online, it is available. If you want to do 100% offline, like you are coming here and doing offline, that is also available. Hybrid model is also there. Hybrid model is what? Part of the course you do online, part of the course you come to institute and do. That is possible. In this, all these modes of training, you get access to the recorded video for 2 weeks for every session. In weekend only, it will be online sessions only. In weekends, there is no offline, but you can come down. I mean, those who are enrolling for weekend course, they can come to the institute for any offline doubt clarification session. Reason is why it is online is lot of people who enroll for weekend courses, working people. In our observation, we have seen that they are more inclined towards online training only. They don't want to come; they want to do from their home only. Here in weekend course, you have access to all the recorded videos for entire course duration. And weekday evening batches based on the availability of the students will do. And all modes of training, every student is assigned with a dedicated mentor for doubt clarifications. Uh, I have already talked about this. Now talking about functional verification training. I told you right in the very first slide, I told you that all these domains are same. Whether I call front end training for freshers, design verification course, RTL design and functional verification, or ASIC verification, all of them are referring to the same course. Okay. Now let's talk about that course. Functional verification training in our institute is for 8 months duration. Though it is 8 months, you don't have to wait for 8 months to get a job. Your placement support starts from the sixth month of the training itself. Purposefully, we have kept it as a detailed course. I mean, as a 8 months course, so that you will learn everything from the basics. Reason is, I told you, right, this domain requires coding expertise. Lot of people who come to the training are from electrical and electronics background, right? 90% of you, 90-95%. Because of that, you won't come with any coding expertise. So that basics also you have to start here. Because of that, we spend that additional 1-2 months so that your programming gets improved. It will be 6 days per week. Sunday will be off, and 4 to 5 hours per day. In this 4 to 5 hours, 2 hours will be theory, 3 hours will be lab session. Okay. I mean, it could be any time between 9:30 to 5:30, but mostly we try to finish it in the first half. But it can be after lunch also. 2 hours theory, around 3 hours of lab session. Every session recorded video access for 2 weeks. We have a portal called as inskill.in, where it's our e-learning platform where you get access to all the recorded videos. All the course presentations, assignments and notes are available. Even we give the hard copy of the course material. The printed material will be given to students. Even those attending online, offline, everyone will get it. Online students will get it by post. Printed course material provided for all modes of training. How this 8 months is split, shown here. Initial 3 months will be focused on advanced digital, some basics of Linux and GVim, Verilog design and verification projects. Deep into Verilog, completely into Verilog. The next 2.5 months will be focused on system Verilog, UVM, Linux commands hands-on, and soft skill training. See, soft skill training is a regular thing. It's not like one only in the end of the course 1 week it will happen. Because what is soft skill training? More like how to improve communication skills, how to improve your interview skills, okay, email writing skills, grammatical skills, how to improve your grammar, English grammar, essay writing, simple essay writing. It could be focused on everything. Idea is
Yeah,
to, can it happen
anything
in one? Sorry, ask your question. See, soft skill training is not something that you will do in 1 week, right? It has to be gradually done. So every week you will have 1 or 2 hours session where the trainer will give you some activity and trainer will make sure that your skills are gradually improving. Okay, that is very important, because when you go to job, even when you go to interview, your how you communicate, how you present yourself is very important. From this point onwards, candidate gets the placement support. You don't need to wait for entire 8 months to get the placement support. The final 2.5 months will be focused on the projects, industry standard projects. There you will also learn Python. There you will also learn ASIC flow and SOC concepts. So this is how the majorly the training is split. And each topic syllabus is also provided here. Everything is done in quite depth. I told you 3 phases, what is done in each phase also. Okay. Uh, Majorly what happens, phase 1 and phase 2 helps in getting the job. Phase 3, where we do the projects, scripting, that is what is really more helpful for you when you get into the job. Phase 3 is what you, these topics are what is relevant for the job actually. But interviews happen based on phase 1 and phase 2. There's a mismatch. How the companies hire, there is a problem actually. Okay, they focus more on this, less on this one. But lot of your work in the job will be around this one, because you will be doing a project, right? For that you should know the industry standard project, how the flow happens, what are the issues and all those things. But anyway, I'm not here to judge how company hires. So in summary, phase 3 is very helpful for you to perform in the job. Okay, how our training differs from other institutes? Mostly all other institutes training stops after phase 2. They will teach all these things. There their training stops. We will focus on this also very dedicatedly. Okay. What about functional verification for experienced engineers? It's a 6.5 months course, 6 days per week, Sunday off, or even they can attend weekend course also, because their experience may be working, so they can even attend weekends also. Uh, Initial phase will teach system Verilog and UVM. Later phase will do the industry standard projects. That is how it goes for 6.5 months. I mean, where the duration is coming down is we are not doing digital and Verilog, which is consuming almost 3 months. That 3 month is reduced, and we are doing additionally UVM advanced topic. That is where it becomes 6.5 months total. Okay, FPGA, let me not touch upon. If someone is very specifically interested, will discuss this during the FPGA session. DFT also has similar flow where training is for 26 weeks duration, 6 days a week, 4 hours per day. Initial 8 weeks will be focused on advanced digital design, Verilog basics, Linux basics, GVim, TCL scripting. This is done during the initial 8 weeks. Later 10 weeks will be focused on the basic topics, CAN, ATPG, compression, simulations, hands-on projects. And phase 3 will be focused on the advanced topic like the BIST, JETAC, and hands-on projects. But your placement support will start from the phase 2, after phase 2 itself. So physical design training, let me not touch upon. How to choose the right course, I told you. You have to decide based on your skill set. If you are interested in programming kind of job, go for front end domain. Otherwise, go for back end domain. We offer one flexibility, as I told you. You choose any course, you can switch to other domain within 2 months. How to prepare for job? Okay. Uh, what is the difficult part of training at any institute, or more specifically our institute? Okay, things move quickly compared to how it was in your btech. In your btech you had a 1 semester time for every subject. Let's say digital design, you are doing signal systems, control systems, okay, network theory, anything you do, it is happening over what, 1 semester time, which is roughly 4 to 5 months time, right? You're getting almost 5 months time to prepare for one subject. Here what happens is, same level of expertise you have to finish in 1 month, but only that subject only you will be doing. In college you are doing 5 6 subjects or one semester. Here you are doing only one subject or 1 month time. So you have to come out of that college mode and get into a different mode where you have to focus on one domain and try to develop expertise in that domain in during that month. Okay. You can think of our 8 months of training, let's say 6 to 8 months of training will give you an expertise of similar to what you learn over 2 years of your BTech time. That much expertise you may even develop during the training. Okay. In summary, what you do in your engineering and what is covered during the training are significantly different, because in engineering, main focus is not to get a job actually. Their focus is more to get percentage, 80 percentage or distinction or 90%, whatever. Here we don't worry about percentage. Companies don't bother about what is the percentage you got in our internal test. Will they ask how much percentage you got? No. How much expertise you have with the subject. So we have to go deep actually. We have to go deep into each subject. Let's say if I teach digital design, I have to teach deep into it. Means I cannot skip some topic. I mean, if I teach digital design, I have to teach each and every topic, starting from the number system, radix, k-maps, logic gates, realization, complements, till we do the advanced topics, applications, sta, everything has to be taught completely. Same thing if I go to Verilog, we have to cover everything in Verilog from basics to advanced. Okay, so that will be the challenging part. But what is that you have to follow is Every day you spend 6 to 7 hours. Let's say you are attending course for 4 hours in a classroom. Another 3 hours from your side. Regularly, if you follow, you will be able to get a job. One problem that everyone faces here is what is done in January month. Let's say January we are doing digital design. By July, they forget. Right? It happens, right? Because if you don't revise, what will happen? You'll forget. When you go to interview in July, they ask you digital design question. Very basic question also you may not answer. Because today what you know, after 6 months, you won't remember that. Let's say you have used Karnaugh map to reduce some Boolean expression. You have used some De Morgan theorem to reduce some Boolean expression. After 6 months, you cannot do. If you go to interview, you tell them that I did January, now I don't remember. Will they accept? No, right? They won't accept, right? Because they'll expect you to remember it. Okay. Same thing happens with what is covered in January, February. Let's say we did February, Verilog language. March, let's say we did Verilog projects. The problem happens with every student, I mean, who finds it difficult to get a job is they don't revise the topics. That is the major problem. Today, what you are doing, you are comfortable, actually speaking. Same level, how do you make sure that same level of expertise you keep maintaining? Okay. Throughout the 6 months or even after 6 months, that you have to find a solution. What is the solution we as an institute have been trying to do? We will give notes from our side. We'll give you one notebook from our side only material, and we are starting January this month. We are giving a notebook, okay, which in which you have to make a notes, not the running notes, not the calculation notes. And notes you have to maintain important points. And every week we are making sure that you submit that. Every week it is submitted, and trainer reviews it. What you have prepared, what you have meant. Why it is important? Because this is my presentation. I will be comfortable at explaining this presentation. Why? I have prepared this presentation. If I give you same presentation, will you be able to explain? No. Why? You didn't prepare this. You don't know the intent. I mean, why did I write this line? I know better. You don't know. When you prepare your own notes, what happens? You know why you have written each line, right? You know why you wrote each line. So you are more comfortable with that. So what is that we understood? One of the thing is student don't revise at all. For whatever reason, I don't want to blame a student. So we have been encouraging them to revise. We have been conducting revision sessions, but it has to come more from where? Student only, right? That I have to keep revising because I have to be job ready. I cannot go and tell that I forgot Verilog because I did in Verilog in February. I cannot tell in the interview that my Verilog was done in February, so I forgot it. I cannot. So given all that, we are making sure that it is compulsory for every student to make a notes. It could be notes or it could be a document. Which document? Online document. You have to submit it every week. That will be reviewed by the trainer, and trainer will give you the feedback how to improvise. That will ensure that you have, by end of the training, you have some notebook, 200 pages, 300 pages, where entire training is captured in those 300, 400 pages, which if you want to just revise, you are able to quickly revise and prepare for the, be ready for the job. And second thing is required is dedication. Every day if you spend 6 7 hours, 4 hours in the classroom, additional 3 hours, by 6 7 months you will get a job. Third is the right attitude means what I told you. You have to work with a passion. Just coming to institute and thinking that institute will give me job won't work. Institute role is only to guide you, prepare you well with the subject, and make you ready for the job and connect you with the opportunities. Institute never guarantees any job. Guarantees means what? We continue to give placement support, but it's the students' hands how much expertise they develop and how good they become. Okay. This last small thing required is aptitude. You should have the basic aptitude skills. Your basic mind itself should be able to do basic logical reasoning. That much level of basic simple calculations you should be able to do. If you do all this, you have a very good chance of getting it done. Even from our side, we track the student performance, how the student is performing. I mean, poor student doesn't mean that we discourage or we keep him separate section, nothing like that. We try to arrange the revision sessions for them. We try to support one-to-one support sessions. Okay, trainer. I mean, our team, there is a one or two dedicated people who monitors the student's performance, and there is action. See, they cannot just monitor and do nothing, right? What is that they do? If someone is not doing well, they try to figure out: is it because attendance is lacking? Is it because they don't understand the basics? Then we try to arrange some backup sessions for them. But then you need to have a lot of proactiveness. To from your side, proactiveness should be there to get the support. Is it a free course or paid course? Paid course. So who has to? You have to, for whatever you have paid, you have to take the advantage of it. So you have to be proactively talk to the team and get the support, because since you are paying, we are answerable to you. If it is free course, nobody bothers. Since it's a paid course, there is an answerability, right? I mean, for every session, for every topic, there is answerability. So you have to be proactive in getting the support. If you don't take it proactively, if you leave it, institute also leaves it. When institute tries to when institute grows when our students perform well. So we try our best effort, but if student doesn't want to come that level, we leave it. Okay, so as part of that, we do assessment. I mean, we check how student is doing with assignments, how student is doing with attendance wise, is coming regularly, how he is doing in evaluation test, presentation wise, how they are doing. And we give you presentation, like for example, we'll give you one topic, you will have to prepare one small presentation, and you have to give it to a group of 15-20 people. That way we will make sure that your communication skills also improved. We'll also conduct mock interviews. We'll keep giving you that feedback. I mean, it's a process which will spread over entire time duration, entire training duration, throughout which it will keep happening. Okay, and we'll create one dedicated WhatsApp group for you, where you can connect with the trainer or our admin for any kind of quick support. What is the final goal of 8 months of training? Student should be enabled to work in the job independently. Let's say you go to any company, you should be able to work independently with minimum support from the company, your seniors. It involves a collective effort where institute will have a role to play. Student also has to put their dedicated effort. What are the course prerequisites? We don't expect any technical expertise from you. We don't expect any technical expertise. You should be one thing you should be good with: quantitative aptitude should be good. Means what? Ability to understand the problem, do basic logical reasoning. Okay, that is one of the prerequisite. Okay. What is the skill set required? I told you, right? Anyway, we are going to teach everything from the basics. At major level, front end means some inclination towards programming, back end means inclination towards tools and technology. Yeah. So this is a brief. Now we will take any question and answers. Do you have any questions?
Hi, I have one question.
Yeah.
So, can you elaborate on the mode of learning that you have?
Which learning? Please tell me.
The modes of learning, like is it like the online and hybrid model and the e-learning mode?
Okay. Majorly, there are two modes of learning, I would say: classroom live online, one is e-learning. Okay. In classroom and live online, we will have in both these modes, we'll have training for 6 days per week, around 4 hours per day. This is the regular schedule. I mean, this is mostly meant for the freshers or who have the availability. Okay. E-learning is meant for working professionals, working people. E-learning will provide you access to all the recorded videos and dedicated support sessions. Recently, what we have been doing is for e-learning people also we are running some dedicated track. Okay. Means, just to give you an example, let's say some 10 people enroll for DV fresher course in e-learning over a period of January to February. Okay, they would all get access to the videos. We are also conducting dedicated evening trainings, evening batches or weekend batches for them separately. The intention is, if I just give you the recorded videos, let's say if I give you 300 videos, ask you to go through all the videos, it is very difficult to learn only with the videos. So we will be conducting the weekend support sessions, and also, as I said, once we have a minimum batch strength, we will conduct a dedicated training for those 10 people, because instead of just going through the videos and learning, having someone guide you how to use the tool, how to run a project, I mean, whatever issues you are facing, if they can support with assignments, you will get much better experience, right? So we have been trying to work towards giving best learning experience to the student. I mean, personally, I've been telling to my team that how to give best learning experience to the student. That's what we have been trying to do in e-learning also. These are the different modes.
So
I hope
how
it
is it
answers.
like for the labs part? How is it with for the e-learning people? How do
Actually,
they?
e-learning, how it works is, over the weekends you'll have the second weekends lab sessions will be done, and as I said, there can be one dedicated track of training also. You will get support every weekend, and also we will run a dedicated training for the e-learning enrolled students. Once we have some minimum count, let's say 10 people, we'll keep conducting some dedicated batches of training. For example, if I do here verilog in classroom, I do verilog for, let's say, 60 hours. In e-learning, I'll finish the same thing in 30 hours, 20 to 30 hours, because you already have access to all the videos. The trainer will quickly go through all the topics again. So
Sir,
in
you told
summary,
weekend.
yeah.
Sir, you
Yeah,
told
please.
weekend course. Weekend course. Weekend. So it is not
Actually,
mentioned
e-learning, you
weekend
can
course.
think of it as a e-learning is also, it's partly a weekend also course.
Okay, sir. Okay, sir.
E-learning and weekend are kind of similar courses only, actually, at least for
Okay, sir.
front end domain. Even in
Okay.
e-learning, you will have the weekend classes, and also you have access to recorded videos. Yeah. Any other questions?
Sir, I have a personal question too regarding me. Actually, I
Yeah.
have done M.Tech in 2022, but I due to childbirth I have a gap of that much year. So, the can you suggest me any course that will be give me a boost to my career?
Actually, you can get into any domain. Again,
Yes, sir.
you could go by whatever I said. Let's say you have some prior exposure to C language, or you have little bit comfort with programming, then you can go for front end domain. Otherwise, you can go for back end domain. You will have an advantage because companies these days have been hiring people with education gap. Some companies, what do they do with that is, They will show your gap, let's say 2022 till now, that's around 2.5 years. They will show it as a internal company experience. They'll show it as their internal experience, and they're able to place you easily. That's where you have a better chance. You can go with any domain for that matter.
Actually, sir, I have a one gap also. 2008 and 10 BTech and MTech gap also is there.
uh, it's
To-
not a so much big concern as such.
okay,
Once
sir.
they decide that they need people with education gap, they're okay with that. It all comes down
Sir,
to see. Please complete.
sir, I want to there if there is an assistant in resume building and
Yes, resume
resume what
building will. Yeah, there will be a dedicated session where the trainer will guide you how to build a professional resume. I mean, it will be like in a one page. How do you capture everything? How do you put it in a more professional manner? That session also will be dedicatedly conducted, and you will be preparing the resume and you will be sharing. Our team will review how you have prepared your resume also.
okay, sir. Okay, sir. Okay, sir. And what you are telling about the education gap?
No, I'm telling you right. In some companies, education gap is an advantage. If I have to make
Okay.
one statement regarding that, today in our institute there is no one 2022 or earlier passed out who don't have a job. There is no one in the institute who is 2022 and earlier passed out without a job. Because what is the
Actually, sir,
advantage they have got is, because of the gap, companies are hiring and showing that gap as a internal company experience. Let's say I'll show your gap as my internal company experience. So you will become 2 years experience engineer or 3 years experience engineer. I'll train you accordingly. I will train you so that you are capable of 2 years work. Then I'll place you easily. That is what is happening.
okay,
So you can get
okay, sir.
into any domain. As I said, you start with any domain, because when you have a confusion, you start with any domain. Up to 2 months anyway, you can switch, right? Because if I tell you today go for functional verification, what if you don't like programming? Let's say I tell you physical design. What if you don't like? That's where we'll give you that flexibility to choose what you want to do. But you do
Okay,
stand a good chance.
okay.
Next.
Thank you, sir.
I had a doubt with respect to hybrid mode. I have a back injury currently, not supposed to travel. So can I attend online for theory part and labs offline? It is possible. Yes. You remember we had told you the same thing in WhatsApp also. It is possible. Means we have many students who attend training from US also. Now they, for any reason also, they cannot come offline, right? So they have been doing entire course online and they have been able to get jobs also. It all comes down to, I mean, if you ask me how can I do labs online,
डालिए लोटा लेके डालिए
please
कहाँ
be
डालिए लोटा लेके बाथरूम करने जा रही है डायपर लगा है तुमको
Shaka, please be in mute.
sorry sir, sorry sir.
Okay. So, one second. Yeah. So what I'm telling is, it is completely possible. That is called as hybrid mode where you can attend whenever you want online, whenever you want offline. It is possible. There is no restriction in that actually. Projects we do by end of the training, how would it be for e-learning mode? Will we do project by watching videos, or as I told you, this is the answer for that. We'll have a group of 10 to 15 people. I mean, even in e-learning, see, actually speaking, our statistics is that, I don't go into the numbers. We have many students who enroll for our e-learning courses. Means if I go here, we have a lot of other courses, okay, where we have a lot of enrollments. For us, and as a e-learning, in last 2024 we would have done analysis, right? 60% of our enrollments, 65% of our enrollments are e-learning actually. 35% is only live training. I mean, including the small courses, DDR course, PC Express course, some short courses, 1 month, 2 months course also including. 65% into what? Only e-learning. 35% into live training. Because of that, we have been coming up with a process where how can we give better experience to the e-learning student. So as part of that, what we will do is once we have some minimum number of students enrolled, we'll run a dedicated training batch for them, not at the regular timings, not at 9:30 to 1:30. We'll find with 10 students what is the timings convenient for them, and accordingly run a training track convenient for them. Abhinav, I hope it answers your question. Even project will be done in live for you in that case.
Yes, it does. Thank you very much. Thank you. Thank you.
Any other questions? I have 2 years experience in. I have 2 years experience in embedded. Do I need to have good knowledge in aptitude? See, aptitude is something everywhere you require. Aptitude is what? Basic logical reasoning, right? It's like telling, if I give you simple example, if 10 people can do a work in 5 days, how many days it will take to for 20 people to do? You should not spend 2 minutes to do that. You should be able to quickly do the logical reasoning and come up with 5 days. That level of basic logical reasoning you should be able to do. That's all I said. I'm not telling you to do a whole 1,000 questions. Basic logical reasoning. Let's say if I tell you simple example, I teach you 1 kilobyte is 1024 bytes, 1 megabyte is 1 kilobyte, I mean 1,000 kilobytes, right? Then I ask you some questions related to that. You should be able to do the logical reasoning and come up with the answer. You got it, right? If I ask you 1 gigabyte is how many kilobytes, tell me. After teaching everything, if you cannot answer, that's a problem. I mean, I'm not expecting now. 1 gigabyte will be what? 1 million kilobytes, for example. That level of logical, I mean, you may say, how is it related to logical reasoning? Ability to understand it in a simple mathematical terms and connect them is what is the minimum expectation. I hope, Harini, is it clear to you? I mean, not that we
Yes.
will be doing that aptitude questions here. That ability to think logically is important. Basic logical reasoning is important. Any other questions? Is it advisable to take the course in my final year? It is advisable. Only thing we will give you flexibility is that you can do the course by splitting it. I mean, we'll give you option to will give option to do it over next 1 year time. One year or 15 months time. We'll give option to do the course over 1.5 years time. Means what? For let's say right now you have time. You do digital and Verilog. You can take 2 3 months break because of college work. Then you can do continue with system Verilog. As an institute, we'll do everything as long as it doesn't impact us. Anything that helps you, we'll do everything. Any other questions? I mean, this flexibility also we can do. People can do that. I mean, I'm not telling that you purposefully take a break, but if for some reason he is pursuing college, he has his semester exams, he cannot continue. We'll give you option to join into the some other batch for next topic. Any other questions? Fine. So we will conclude the training. Only one. I'll conclude with only one last thing. Uh, you are joining the course. I mean, you would have seen our fees and some other institute fees also. don't go by the fee part. I mean someone else, I know, right? I mean, when I run an institute, I know what is the fees charged by the institute. There are hardly 5 6 institutes. I know what is the fee charged by each institute also. We purposefully keep it less so that it becomes affordable and manageable for everyone. So we do some things in such a way that we are able to manage it. Let's say if I'm charging some x amount, what you know, right? It's our own building. We relatively get the softwares, which is a major part of our cost. Software means what? The tools, at a relatively lower cost compared to other institutes. How we get is a different thing. I won't get into it. Okay, because we offer at a less cost, they offer at a lower cost to us. Okay, essentially we are able to manage it. Okay, we don't really go with too much posh infrastructure, posh building and all that. Doesn't matter, right? For when you come for learning, do you care about learning, or do you care about infrastructure? Mostly learning part. So that has been our focus. Mostly our training feedback had been good. I mean, we keep reviewing. I personally stay here only in the same building, so I keep checking how the training keeps going on for every batch. So we keep monitoring. So that is how the fee is less. So do not think that someone charges 1.5 lakhs, so they charge less, so is there any big difference in the quality, right? It's not like that. We do give a best possible quality of training. It's just that as a policy, we have been trying to charge less. I mean, it was all questioning. Like for my son, I pay 1.5 lakh for second class. For his second class, we overall expense comes to 1.7 lakhs. There I started questioning, should it be so much? Now can I go and change the school? Can I ask them take only 70,000? They won't listen, right? They will say go to some other school. So why can't we do that? That, I mean, even as a business, it runs easily for me, because as at a lesser cost, it runs more consistently. Okay, that had been the thing. So in summary, don't think that there is anywhere quality is not compromised. Okay, and yeah, placement wise, again, I'm telling you, lot of things is in student hands. You join only if you are serious about training. Do not join, again, listen this sentence carefully, do not join with the assumption that institute will only get you the job. It's all your effort. It's in your hands. You have to build your career. Institute is the thing that gives you the direction to your learning, career, everything. Institute will connect you with the companies. Institute will give you right guidance, but lot of things are in your hands. See, you have to be proactive. You have to learn the subject. You have to develop the passion that someone else cannot do. Like, that's the some concluding thing. But I gave you a few guidelines. If you write a proper notes, you revise the things, you do in a systematic manner, there is a very good chance of getting a job. After the completion of the course, do I have access to the videos? At a nominal cost you get. I mean, I think up to another 1 month or 2 months they will provide you the access. After the course also, up to 1 or 2 months they will provide the access. Beyond that, they will charge nominally 500 per week. Some cost will be there that you have to pay to get access to the videos. uh, can you tell me one last question? Let's take. Okay, for e-learning mode, are the courses given by you? Yes, we do that. I mean, if you go to our website called as inskill.in, this is our platform where you will get access to all our e-learning courses. So in this portal, whatever courses are there, these are all available in our e-learning mode.
Actually, what I wanted to ask is that for the e-learning mode and functional verification, are the recorded videos, is it recorded by you or by some other instructor?
Yeah, these are all my recorded videos only. Functional verification
I
is
see.
my
I see.
recorded videos.
Okay. Okay. Thank
Next.
you.
Can you please tell me in e-learning mode of DFT training, which is supposed to be self-paced, at which phase will the placement support be provided? I mean, basically, once you complete around 85% of the course, placement support will be provided. Means you can even finish the entire thing in 3 months. Your placement support will start after 3 months only. But how do we judge that we will provide? We'll conduct an interview for you, mock interview. Based on your performance, we'll do. If your performance is good, your placement support will start. Otherwise, we'll give you feedback where you have to improve. Then we'll provide the support.
పెరుగుద్ది. ఏం పెద్ద పెరగదులే. అంతే ఉంటది.
Please
ఆయిల్
be in
కొంచెం
mute.
వేస్తావా ఇందులో?
Please be in mute. Okay. In regular session, this kind of disturbance won't be there. People will get used to it, so they will follow the training etiquette. Okay. I'm 2021 graduate in EC. Then I pursued my MBA, graduated. Now I'm working in HR in a VLSI company. So now I want to switch to technical. Yes, it is good to start. It is possible and very much possible, because if you are working in the VLSI domain, you know how the hiring is happening, right? I mean, someone who is working in a VLSI company, they know that someone who has passed graduated in 2021, they have a very good chance of getting a job. I mean, I don't need to tell. You can internally check, because companies show that internal gap as a experience. So if I tell you, let's say simple example, Qualcomm, if I tell I'll give a fresher or I'll give a some 3 years experience person, which one they will prefer? Experienced person, right? So that's what these people are used for. But only in all the cases, what is the challenge you will face is, you will have to, prepare, right? Because as a fresher they will have a lot of time, but as an experienced person, okay, as a working professional, you have to take out time and prepare. In this case, for getting a job is not a challenge. Opportunities also you'll get. The bigger problem will be, while working for 5 days 8 hours per day, how do you take out time to prepare? If you are able to do that, then you can pursue this course. Next, can you suggest me front end or back end? Again, I would suggest back end. Let's say, again, it's your choice, personally your choice. But only thing I can tell you is, I'll give you option. If, can I go and ask my interest to someone? No, right? I have to choose what is my interest. Whether am I interested in front end or back end, I have to go by what is what is skill set that is interesting to me. But as an institute, I give you flexibility to switch. After 2 months or 2.5 months, you come back and tell, I'm not able to cope up with back end, I want to switch. Then I'll give you that flexibility. Which companies can prefer freshers? Almost every company requires freshers. Okay, there are two kinds of companies, product and services companies. Majorly, okay, let's be frank, 90% of the hiring in institute happens into services companies. Okay, product companies hires from IITs and NITs lot of times. But does it mean that you can't get into services product company? You can always get in. You develop a passion. You should become so good. I mean, you should start enjoying the subject. With that passion only, lot of things will happen. Actually, I gave you one example, right? One person whom I know, yesterday only I met. Okay, just in a casual discussion, he told me his salary numbers. Okay, he's not from IIT and NITs. He's from one government college, JNTU kind of colleges. In Andhra, there will be JNTUs, right? Those kind of colleges only, university college. And now he is in that level. So it's possible. You don't need to be from top colleges or anything. Over time, he has taught the subject here. He became expert with the subject, and then in the work also he has shown the same passion. Now he's able to get that level. So you can get into any kind of company once you have that content, that subject and depth you have. You can do everything. The only thing is, you have to maintain the same motivation level for 6 7 months. I mean, whatever motivation you have in January, do you have same motivation in June, July also? That's important. Okay. Any other questions? Okay. Those attending online, do you have any questions? Okay. So we will conclude the demo session here. The The course will start on Monday it will be starting. Okay, for first 2 3 days some basics will be covered, Monday and Tuesday. Wednesday onwards digital design will start. Why we have given 2 days for basics is people enroll Monday and Tuesday also, sometimes they get delayed. So we will start main training will start from Wednesday, but Monday and Tuesday also some useful topics will happen definitely. Okay, that is about it. If you want to enroll, you connect with our team. You can pay 5,000 and confirm your enrollment. This is where you do. Okay, you can pay 5,000 form, and there is a link you have to fill, one enroll form you have to fill and confirm your enrollment. So for any other queries, you please connect with our team for support. Okay. So we'll end the session. Thank you so much.